Good evening, everyone.
Good evening, sir.
Good evening.
Good evening, sir.
Okay, so shall we start today's session?
Yes, sir.
Okay. My screen is visible, right?
Yes, sir.
Okay. So please join peerdeck.com. So join pd.com, sorry. Join it. The code for joining it is this one, RYNPVK. Okay. Only 12 students have joined. Others, please join. Okay. So okay. Others who did not join the joinfield.com, please join this joinfield.com by using this code, which is top right, which is RYNPVK. So we are moving to
Yes.
a question. Okay. This is the first question. Question is, suppose that the number of customers reaching a particular shop in a 1 hour time period follows the Poisson distribution with an unknown parameter lambda. Okay. Previous records suggest that the prior probabilities of lambda are probability that lambda equal to 5 is 0.4 and probability of lambda equal to 7 is 0.6. If so, we know the prior probabilities for lambda, okay, from the previous records. That means we know that probability that lambda will take value equal to 5 is zero point 0.4 and lambda will take value equal to 7 is zero point 0.6. If in a particular 1 hour time period 9 customers reach the shop, find the posterior mode of lambda. Okay, so here you have to find the posterior density, and from that you have to find the posterior mode. So you know how to what will be the posterior mode.
Sir, if probability of lambda given sample,
Hmm.
lambda equal to 5 given sample is
So
either of the both is
yeah,
greater than, then
yeah,
that will be the posterior
correct,
mode.
correct.
Yeah.
So what you have to do is you have to find the probabilities when lambda equal to 5 given that the sample, and when lambda equal to 7 given that the sample. So if you find that probability, you'll be able to find and then you have to compare. So whichever the highest probability is there, that is your posterior mode. Okay, so take 5 minutes for solving this and then we'll discuss the solution. So those who have joined late, so you can use the top right code in joinperiod.com, that is period. The code is RYNPVK. Okay. Okay, I have got 8 responses out of 25, 21. 21 who have joined the periodic. So just if anyone is having doubt solving here, please let me know. Okay, so shall we discuss the solution now?
Yes, sir.
Yeah. So see what are the answers. So answers are 7 is a mode. 7 is a posterior mode. Some people said 5, 0.3, 0.6757. Okay, 0.8. Okay. Okay, so majority is 7, right? Okay, we'll see. The question was, we know the prior probabilities of lambda, which are when probability that lambda equal to 5 is there, it's the probability is 0.4, and probability of lambda equal to 7 is 0.6. Now the posterior probability of lambda will be probability that lambda equal to 5 given that x equal to 9, right? So our sample was 9 customers arrived in 1 hour, right? So given that 9 customers arrived in 1 hour, what is the probability that lambda will take value 5? So by using the Bayes rule or conditional probability, so here actually Bayes rule we are using. So what is the conditional probability here? Probability that lambda equal to 5 given that x equal to 9. Our numerator will be probability that lambda equal to 5 intersection x equal to 9, right? And divided by probability that x equal to 9. So that numerator can be written in this format, probability that x equals to 9 given that lambda equal to 5 into probability that lambda equal to 5. So what we know here, we know probability that lambda equal to 5, right? Which is what? 0.4, correct? And probability that x equal to 9 is what? How to find probability that x equal to 9?
0.6.
How? 0.6?
We will take the law of total probability.
So okay, a lot of people, okay, law of total probability, right? So we'll see.
Yeah.
Okay, for now we'll discuss about the numerator. Okay, so tell me probability that lambda equal to 5, it is given, right? The prior probability, which is 0.4, right? That is okay. Everyone is okay with this?
Yes, sir.
Yes,
Okay.
sir.
Okay, then what about this probability that x equal to 9 given that lambda equal to 5? So what does this mean? Probability that x equal to 9 given that lambda equal to 5.
We have to use the Poisson's distribution at which lambda value equal to 5,
Lambda equal to 5 and x equal
x
to
equal to 9.
9. So what is the Poisson distribution? E to the
Uh,
power minus lambda, lambda to the
Lambda
power
raised to
x,
k divided by
x
x
factorial,
factorial. Yeah.
right? And x is here 9, correct? And lambda is equal to 5. So by plugging in all those values, we'll get e to the power minus 5, right? E to the power minus lambda. So e to the power minus 5, lambda to the power x. So 5 to the power 9 divided by 9 factorial, right? These three terms here into 0.4, which is provided that lambda equal to 5, right?
Yes,
Correct?
sir.
Okay. Similarly, we can find probability that lambda equal to 7 given that x equal to 9, right? The same rule we can apply. So
Yes.
by using that rule, probability that x equal to 9 given that lambda equal to 7 and probability that lambda equal to 7. So we have already given probability that lambda equal to 7, which is what? 0.6, and probability that x equal to 9 given that lambda equal to 7. What is this probability? Again same, right? Here lambda is 7 and x is 9, and we know the Poisson distribution. So it is e to the power minus lambda, lambda to the power x divided by x factorial, which is nothing but e to the power minus 7, 7 to the power 9 divided by 9 factorial. So here in both of these equations, what is the common term? Probability that x equal to 9, right?
Yes, sir.
Yes, sir.
And we know that
Yes.
so in both the terms, some value will be there, definitely some value will be there for probability that x equal to 9, correct? But in
Yes.
both the equation it will be same, right? Whatever probability it will be having, it is same.
Yes,
So
sir.
if and in this question what we have to do is we have to compare the two probabilities, right? So if you wanted to compare two probabilities, probability that x equal to 9, if you don't calculate also it's fine, right?
Yes, sir.
Because anyway it is going to get cancelled, correct? Correct.
Sir, here you are saying that if these are two are same, that's why you're canceling out, right? Because x
Yeah,
equals to
because x
9 is
equal to
the
same probability will come,
same.
right?
Okay, in both the equation, x equals to 9 will be
No.
same. Probability will be same
Yeah, why it is same?
because
So it is from the same distribution, right?
same distribution.
So x equal to 9 is Poisson distribution, right?
Mhm.
And it is coming from the same since it is coming from the same distribution, the probabilities for both the cases will be same, correct?
Okay.
So we are not going to find the probability, right,
Mm-hmm.
for x equal to 9, because since we are comparing it here, so we are
Okay.
comparing it, no need to find, it will anyway it will get cancelled, right?
Okay.
So suppose probability that x equal to 9 is 0.5, let's say.
Mm.
Hmm? So 0.5 and 0.5, both the cases it will be
Cancel.
same, so it will get cancelled. If I do this, so what we'll get here?
Sir, why are you dividing 2 by 1?
Okay, you can divide or you can equate it, right? Or what?
Means we are
How to?
comparing, right?
So how to compare?
So both should be equal. I mean, we can.
Okay, anyway, see, if you don't want to divide, what you can do is you can calculate this. So what is can you calculate this one? E to the power minus 5 into 5 to the power 9 into 0.4 divided by 9 factorial.
Mhm.
Yeah, no, what I'm saying that
Okay.
if you wanted to
Just,
calculate, can you calculate?
yeah, I can.
Yeah, please. Can you tell me the value?
At 0.19.
So 0.19 divided by probability that x equal to 9, right? That
No,
is
overall, sir.
yeah. So everything is 0.19, right? And divided by probability that x equal to 9 is there, correct?
Yeah, after calculating all, I am getting 0.19.
So you have found the
Probability of lambda is equal to 5 given x is equal to 9 is 0.19.
so you have found the value for probability that x equal to 9 also. You're saying?
No,
Huh.
y- yes, sir. X is equal to
By
9 also.
dividing.
Yeah,
No, I don't understand. Which value you have calculated?
probability of lambda is equal to 5 given x is equal to 9.
It's 0.014.
0.19 and 0.81 for probability of lambda is equal to 7 given s is equal to 9. X is equal to 9. Yeah.
This was the first equation, right?
Yes, sir.
And provided that lambda equal to what 7 divided given that x equal to 9 is e to the power minus 7 7 to the power 9 divided by 9 factorial into 0.6 divided by provided that x equal to 9, correct? This is my what, sorry, okay. This is my second equation, correct? Now if
Yes, sir.
I don't divide also, in case let's say we are not dividing but we have to find some value and we have to find some then only we'll be able to compare, right?
Mhm.
Correct. So what is this value?
Sir, total numerator is 0.014.
Okay, the numerator is
0.014.
0.014 divided by provided that x equal to 9, right?
9.
Okay, so whatever value it is having, it's okay, some constant value will be there, right? That is true, right?
Mhm.
For this second equation, what is the value of this entire thing? Huh?
Sir, it's 0.06.
0.0
0.060.
divided by provided that x equal to 9.
Yeah.
So both the things are constant, right? So which
Yes.
is greater one?
Greater one is, sir,
0.06
0.06.
upon probability x is equal to 9.
Okay, which is greater?
0.06.
This one greater, right?
0.06.
This is greater, right? How you have found out this? Because we did this calculation, right? So that means if I divided 0,
We calculated it.
this can be
Means
cancelled, right? And I can say 0.06 divided by 0.014. So it will be greater than 1, right?
yes, sir.
Correct. So when my this value, so when why 0.06 is greater than 0.014? Because when I divide by 0.06 by 0.014, it is giving me value greater than 1, right?
Hmm.
So hence we can say from there also we can say that this is greater, right? Here by looking at values also we can say, but in other case if I do division operation over there, and if and how can I say that equation 1 is greater than equation 2 or equation 2 is greater than equation 1? What I'll
Based on the value, no? Like if it is less than 1, then equation 1 is
yeah, so if I divide equation 1 by equation 2,
Hmm.
and if this value comes out greater than 1, then what does this mean?
If it is greater than 1,
This means first is
So
greater
1 is
than
greater
second.
than 2, right?
Yeah.
1
yeah.
is greater than 2.
This 2 will go to that side, right? So 1 will be greater than 2. In this case, what will happen?
2 is greater than 1.
So it will be 1, right?
Lesser than 2.
Right. So here what is happening here? 0.014. So I'm saying 0.014. This is equation 1, right? Is less than 0.06, which is equation 2.
2.
So if I divide equation 1 by equation 2, what I'll get? 0.014 divided by 0.06 less than.
0.23.
So some value it will come, right? What value it will come?
0.23.
0.23, which is less than.
Less than 1.
So I can say that this is equation 1,
Equation
right? Equation 1, this is equation 2. So what I'll say is equation 1 is
less than
equation
2.
2. So this is the way of comparison, right? So
Okay.
what will happen if I do division operation is this 9 factorial and 9 factorial, you need not to do calculation, it will get cancelled, right? Again they provided that x equal to 9 and provided that
Yes,
x
sir.
equal to 9, it will get cancelled.
Cancel.
On dividing, what we are finding, sir, ultimately?
The number, right? What we are finding is
0.23, it's okay, but
yeah.
what we'll be understanding by that one, 0.23.
So 0.23 means the value, this probability value, that lambda equal to 7 given that x equal to 9 is greater than probability that lambda equal to 5 given that x equal to 9.
That's obvious from the equation 1 and 2 only itself, sir. So what we can infer from this information?
How it is obvious? Okay, 1 minute. Okay.
Point 0.014 is lesser than the 0.06, sir.
Yeah, that is okay. That is okay. That's what I'm saying. But when I say this thing here,
there itself we are able to understand that which one is bigger kind of thing.
How?
So why no?
Okay, how you found out from this two?
Because of the numbers, because denominators are same, we can cancel that
Cancelled
one. So
out.
which bigger one number is we are able to find out from equation 1 and 2.
So
That's
we
okay,
have
sir.
to.
Why we are dividing it again, sir?
So
That's
whatever
the
you are
question.
doing right now, right? Whatever you are saying, it is get cancelled out. That means what you did.
Yes, sir.
When we are comparing, yeah, cancelled out, it's okay, sir. Why we are, I mean, on dividing with one another, what we are inferring out of it, sir? That is my.
We are not inferring out of it. That is only the comparison only. Whatever you are saying now, right? That is same thing we are doing, right? What you said, the denominator is cancelled out. How the denominator get cancelled out?
Dividing by
Unequating,
dividing.
yeah, unequating.
On divide.
Equating, dividing.
You divided it, right? So that's why it got cancelled, right?
Yes, sir.
Yeah. Ultimately, what is the greater than one, less than? What we can infer by getting a greater than one and less than one?
Greater than
What is the
one means
difference?
what? Greater than one means what here? This numerator is greater than the denominator, right? So and what is the numerator here?
Numerator. Sorry.
Lambda equal to 7 given that x
7.
equal to 9, right? So this probability, the numerator one, this probability that lambda equal to 7 given that x equal to 9 is greater than what? Probability
Lambda
that
is equal to 5. Okay, sir.
that is equal to 9. That is what we are found. We can understand by saying that the ratio is greater than 1. Okay, and from that what we can say is since this probability for lambda equal to 7 is greater than lambda equal to 5, so our posterior mode is
Posterior mode is 7.
Lambda equal to 7. When that lambda equal to 7, we'll get higher probabilities.
Okay.
Understand, right?
Yes, sir.
So that division operation is what we are doing actually comparison. Same thing, right?
You mean to say which one would be most suitable kind of thing out of these two? That is the comparing what we are doing ultimately, sir.
Which is the mode? What is mode? Generally, what is mode?
Mode is most probable kind of thing. I mean
Yeah,
to say repetitive.
Yeah, so that means the thing which is repetitive, it is mode, right?
Yes.
So and that means it is having higher probability of occurring, correct?
True, sir.
So when my probability that lambda equal to 7 given that x equal to 9 is higher than probability that lambda equal to 5 given that x equal to 9, that means occurring lambda equal to 7, occurrence of lambda equal to 7 is more than 5. Lambda equal to 5. That means what?
7 is the mode.
7 is the mode. Posterior mode, right? Okay.
This is a Bayesian method.
Okay,
Yes.
right?
Yes, understood. Thank you. The mode means the most occurrences kind of thing. Or these two.
So, so that means the value, at what value of lambda we are getting the higher probability. So when my lambda is equal to 7, we are getting higher probability.
0.06.
Then lambda equal to 5. That means there is a chance, there is more chance that my when sample equal to 9, right? That when x equal to 9, there is higher chance that my distribution mean, so which is lambda equal to 7, right? Poisson distribution with parameter lambda, that means it is what? Distribution mean, right? Okay, what is the mean for this thing? Poisson distribution?
Lambda.
Lambda only, right?
Yes.
Or you can say the parameter. There is higher chance that my Poisson distribution with lambda equal to 7 has higher chance of occurrence than when my lambda is equal to 5. Lambda will take value equal to 5.
Yes.
Okay, this is the second question. call duration of daily stand-up meetings of employees of a certain company follows the exponential distribution with an unknown parameter lambda. Okay, duration of last 12 meetings are 35, 30, 25, 15, 25, 20, 20, 28, 34, 30, 15, and 23. Okay, find the Bayesian estimate or posterior mean of lambda using the prior distribution of exponential 1 by 20 for lambda. Okay, so whatever things we have given here, we have given the prior distribution, right? Okay, what is posterior? How to calculate posterior mean? What you have to find first?
Likelihood
times
times
Yeah,
the
so yeah,
prior.
so first
prior.
of all, you have to find posterior density, right?
Hmm.
Which is directly proportional to likelihood into
Prior.
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 And once you find the posterior density from
Yeah,
that distribution of the posterior density, how to find posterior mean? So if it is gamma distribution, then what is my posterior mean?
alpha by beta.
Alpha by beta. If my posterior density is beta distribution, then what is my mean?
Alpha
Alpha
upon
divided by
Alpha
alpha
plus
plus
beta.
beta.
If my posterior density is Bernoulli, then what is my posterior mean?
N times P.
Yeah.
N times p.
Bernoulli is P, na? Bernoulli is
Bernoulli's
P.
Hmm.
P.
P,
N times P, yeah.
NP.
like that. So first of all, you have to find posterior density, and how to
Hmm.
find it? Likelihood into
Prior.
prior, right? So prior is given as exponential with parameter 1 by
1 by
20.
20.
Now how to find likelihood?
Likelihood. Product of all the IID samples.
Yeah,
I mean,
yeah. So the
yeah.
PMF actually. So you have to
PMF. Yeah.
multiply with that PMF, right?
Hmm.
So how many times you are going to take the product here for likelihood?
12 times.
How many instances are there? 3, 3,
Yeah,
6,
12 times,
and
right?
12 times.
12, 12.
Okay, done. Yeah, take 5 to 7 6 minutes and finish it.
So, sir, we have to, for calculating likelihood, we have to take PMF of this exponential distribution. Hello. Hello.
Okay. Okay. Those who have joined late, please use joinpd.com to join to this periodic session, and use the top right code, which is RYNPVK. Okay. Okay. So I got 10 responses. Only 21 have joined out of the 42 participants here. Okay.
Sir,
Let's
in
see.
how many decimal places we have to give answer?
Yeah, you can write like 2, 3, max 3, 3. That is fine. Hmm?
Okay.
Do you need some more time, or shall we discuss the solution?
We'll discuss, sir.
Sir,
Okay.
can you give 5 minutes, sir? Or
Okay.
2 minutes?
Okay. 2 minutes. Let's take it.
Okay. Yes.
Okay. So we'll discuss the solution now. So I think the correct answer is 0.043 or something. Okay.
Hmm.
Okay. So this symbol is like lambda. Okay. Capital lambda. So let capital lambda be the prior distribution of lambda. Right. From the given information, we know the distribution of prior. Right. So f capital lambda of lambda is what? Exponential 1 by 20. So that means it is equal to what? What is then density of it? Since lambda is equals to 1 by 2, we know what is the density for exponential distribution. It's lambda e to the power minus lambda x, right? Correct?
Yes, sir.
Yes, sir.
So here x is what? Here x is lambda, right?
Yes, sir.
Yeah.
Correct? So don't get confused with this lambda and this thing, right? So this 1 by 20 into e to the power minus lambda by 20. Since so this is the distribution for prior. Now posterior density is directly proportional to likelihood into prior density, right?
Sir, excuse me.
Yes.
Sir, this you said lambda is 1 by 20, right? Not x.
Okay, I will just maybe let's see. So what we know what is prior distribution. It
It's
is
exponential
exponential with parameter what?
lambda
1 by
1 by
20.
20.
Not lambda. Here parameter either, which is lambda. Sorry, 1 by 20, right?
Hmm.
So suppose this is, let's say, okay. We'll see the question once again, and we know the distribution of employees. So
Hmm.
the call duration of
It's
employees follows the distribution,
exponential.
exponential distribution. Correct.
Hmm.
So this is a different thing, right? So exponential distribution with what? Unknown
Lambda.
lambda, right? This is unknown lambda. Okay.
Okay.
This is known to you, right? The prior
Okay.
distribution is known to you with parameter 1 by 20, and this
Hmm.
prior distribution is what is for what? For this lambda, right?
Hmm.
Correct.
Okay.
Okay.
So, sir, what we are taking 1 by 20 here?
So this is the prior distribution, na? This
Yeah.
prior distribution, right? This is, let's say, it is lambda 1. Call it as lambda 1.
Okay.
Okay. So posterior density is directly proportional to what? Likelihood into
Times prior.
prior. Okay. So for likelihood, how many samples are there? Total
12.
samples are there, right? And here, if you see how we have, so this is called likelihood, right? Probability that x1 equal to x1. Likelihood is given that correct,
Yes.
and this lambda is unknown, right? This lambda is unknown to us. Okay. So this likelihood, how we'll calculate? This is for what? This is for this exponential distribution, right?
Hmm.
So how to calculate this is probability that product of I equals to 1 to 12 e to the power minus lambda
X1.
xi
Xi.
into lambda,
Hmm.
correct?
Yes.
This lambda is unknown to me. Now for prior distribution, this is prior distribution. So how to calculate, how to find this prior distribution? So 1 by 20
Hmm.
e to the power
Minus
hmm,
x by 20.
hmm?
Minus x by 20.
But what is x here?
X is x from x1 to xn. 12, sorry.
Huh? See, this is the
So,
function of lambda, right?
okay.
The prior distribution
Hmm.
is a function of
Lambda.
lambda. Okay, in another format, okay, I'll ask you one more question. Okay, so let's say when x is a function of, x is a random variable, or x is parameter 2 is a distribution for this x. Okay, so what is
Yes.
the function for x?
2e
Given
to the
function
power minus
2 to the power
2x.
minus 2 x.
X.
If this is a function for lambda, then how will I write?
2e to the power minus 2 lambda.
Correct.
Okay.
So here, what is this? The prior.
Prior for
Prior is
lambda.
a
Okay.
prior is a it is a
Yeah.
function of
So,
lambda, right?
mhm.
So here this is lambda 1. Okay, but
Okay.
this is exponential with 1 by 20. This is lambda 1 or
Yes.
some parameter is a
Hmm.
function, is a distribution
Function.
for
Distribution.
lambda. So that means
Okay.
it should be a function of
Lambda.
lambda. So
Yes.
1 by 20 e to the power minus lambda by 20, right?
Lambda beta. Yes.
Now you understand the difference, right?
Yes,
Between
sir.
likely, why we are using
Function
xi here.
means for unknown parameter we are taking right prior.
So the
So that
prior
unknown parameter should be used in the formula.
in that
Means
formula, right?
hmm.
So that is what, so here it's okay, x1 x2, because we are doing it for sample, that
Samples.
likelihood, right? And
Hmm.
this is prior is a function, prior is a distribution for unknown parameter.
Yes.
Okay.
Okay.
So if you multiply these two, what will happen then? Should I do the calculation?
No, sir. It's fine.
Okay, I think now we'll do it properly. Okay.
It's already derived in the lecture, sir.
Okay, that is there now. Okay, then it's fine.
Hmm.
So lambda to the power n into e to the power minus lambda, and this is x, because this until what point it will go? 12, right?
Yes.
Okay, you can add it later also, or there itself you can add it. That is not a problem. So if you multiply these two, what will happen? Lambda to the power n e to the power. So this 1 by 20 will be a constant, right?
Yes.
What is added here 1 by
Um,
20?
That's 300 actually.
300.
Do the calculation, please, sir.
Okay, we'll
Three.
do the calculation. I think, yeah.
I have a question here. Just can you go back to the previous thing where you were actually showing? See, here we have mentioned it as lambda power n e power minus lambda. Okay, lambda e power minus lambda x is what it is. Here, next, the prior we are calling lambda as 1 by 20, and still we are writing another lambda at the top.
No, that is what I explained here, right? Okay, I'll explain it once more. Okay.
That is ML into fx.
So okay, first of all, my prior is given as what? Prior is having a distribution of exponential
Exponential 1 by 20.
1 by 20. So
Correct.
prior is for what? The unknown parameter, right?
Parameter.
Yeah.
So I can say that this lambda, for the distribution of this unknown parameter lambda, is exponential
1 by 20.
1 by 20. For example, if say x is having distribution of, let's say, not normal, let's say some other Poisson with parameters, let's say 5. So how will you write this?
5 e to the power
E to the power minus 5.
5x.
Then 5 to the power.
Sorry, e to the power minus 5.
Lambda to the
5
power
to
x,
the
right?
power x.
And divided by
factorial.
x factorial. So that means x was unknown here, right?
Yes.
For the values taken by this x, we are finding the distribution. So here, for this is the distribution for lambda, right? This is different one. This is lambda 1 or some parameter for this distribution, exponential distribution. How will you find the distribution for this lambda? Okay, what is the what is the exponential distribution?
Lambda e to the power minus lambda x.
Okay, prior itself is a variation distribution of lambda.
Yeah, prior is a distribution for lambda. That means it is a variable. Lambda is a variable here. So for that, what should I do? E to the power. So lambda e to the power. Okay, lambda. Okay, I'll say lambda 1 here. Okay, this is lambda 1. So how will I write it? Lambda 1 e to the power minus lambda 1 into lambda, right?
Yeah.
And this lambda 1 is what? 1 by 20 e to the power minus lambda by 20, correct?
Yeah.
So this is the distribution of prior. Okay.
Yeah.
Now in my posterior density, it is directly proportional to likelihood into this prior or prior density, right? Okay. This point is clear, right?
Sir, Srikanth sir used to take a different color palette kind of thing. So present and difference, if it is different colors, then it will be easier for us to understand at least at this moment.
No, okay. What is the confusion here? Tell me. No,
nothing. Likelihood is a past kind of thing, and now we are calculating with the previous. So what we need to take it from the data that is given. Some past information, present information, what we are.
This is past information, no? It is called prior. Prior is based on the past information. We are saying that the distribution of lambda looks like this.
we are now considering it. I mean to say likelihood is a past one compared to this previous.
No. Okay, okay. Tell me how to find the likelihood. So we have 12 samples here, right?
Yes, sir.
And each of it is having a distribution which is what? Exponential one. Correct?
Yes, sir. Because
Right?
we are having a small x, capital X, and sometimes small x is sample and single sample, and sometimes it's a set of samples. So there we are getting something here and there kind of things. That's all.
Okay, I'll do something. So let's say x1, x2, x3 until xn or x12 in this case, right? Correct? Is having which distribution? These are
Exponential
IID
1
x.
by 12. Yeah.
Okay, let's say these are IID x, right? And this x is having what distribution? Exponential lambda. Okay, which is unknown here. This is unknown parameter. Hmm? That is
1 by
okay, right?
20, na, sir? 1 by 20, na?
Yeah, that's okay.
No. See, this is for sample,
Okay.
and from the prior information, I know that the distribution. So, what does this prior information will give you? Prior distribution will give you that the distribution of unknown parameter lambda, right? So the distribution from the past information that lambda will take values, or lambda can also lambda is actually, it's not a constant here, right? It's a variable, so it will take different values here. So it is having a distribution of its own distribution, so it varies according to exponential 1 by 20. Okay, maybe you're having this confusion because this exponential distribution, I guess. But let's say from the prior distribution, I know that lambda is, so the lambda varies like, let's say, binomial 5 comma 1 by 2. What does this mean? Okay, you guys are getting confused with this. So suppose,
Format is very simple, sir. Whatever it is, binomial or exponential or whatever it is, we multiply with the
the other
ML.
thing is fine. The other thing is fine. Okay, yeah. But the thing is, you are understanding what I'm saying. This x1, x2, x3 to xn, these are the samples, right? These are the samples taken from some distribution, or these are IDX samples, right? From this distribution, you have selected these samples, correct? And they are having, so this x is having what? Distribution exponential with unknown parameter lambda. Okay, but this lambda is also having a distribution, and from our past experience, we know that this lambda is having a distribution as like this, exponential 1 by 20. So actually this lambda is not constant, right? What previously you have seen in multiple random variables, what you have seen is exponential, here itself it is having exponential 3 or something, right? That means whatever samples you are drawn from the population are varying as per this distribution. Okay, but it is possible that this parameter itself is not a constant, it is having some distribution, it is also varying, it is also a random variable. And let's say this is a random variable lambda, it is having a distribution exponential 1 by 20. So this random variable x is having distribution exponential lambda, but this lambda is also having a distribution which looks like exponential 1 by 20. This is a setup right now. Okay, then we have to find the posterior density. So how to find the posterior density? It is directly proportional to likelihood into prior or prior density, I'll say. So likelihood of this, how I will find it, is equal to probability that x1 will take some value x1, x2 will take some value x2, up to xn, or here in this case x12 will take value equal to some x12, given that my lambda is having some distribution, right? So I'll say this lambda is having some distribution, or maybe I can do this thing. I will do this capital lambda here, okay? And this capital lambda is having the distribution exponential 1 by 20. So lambda equal to small lambda, okay? This is my likelihood, and I'll write likelihood like this also, right? Probability that x1 equal to what? This 35, then 30, then 25, like this. X1 equal to 35, x2 equals to 30, x3 equal to
25, 15.
25, like this, right? 25 and so on until x12 equal to x12 equal to 23, given that lambda equals to small lambda into prior density. What is prior density? Since my prior is having the distribution like this, okay, so this density is given as 1 by 20 e to the power minus lambda by 20. So this is what, you know, this actually,
This would be the correct notation, sir.
okay, that is okay, right?
Yes, sir.
So lambda of lambda is what? This is what. So generally how we write actually, you know, x of x, right? X of x is a, or fx of x. So I'll say if my lambda is equals to this, then my f lambda or f lambda of lambda is equals to what? So this is lambda. F lambda of lambda is equals to what? See, you guys are say, okay, tell me, when my x is having distribution like this, x is having distribution of exponential 1 by 20, and if I wanted to find fx of x, how will I find? What is the formula for this?
One by 20
Hmm?
into
E to the power
e to the
minus
power
x by
minus
20.
1 by 20x.
So I can write x by 20, right?
Yes.
Okay, this is okay, right? Instead
Yes.
of that, what I'm saying is, this is my capital lambda, okay, is having this distribution. I wanted to find density for this. So this can be written like this: f capital lambda of small lambda is equals to, you're understanding the analogy here?
Yes, sir.
Yes,
This
sir,
part,
understood,
Yes,
sir.
sir.
sir, this part is clear. Now let us complete the remaining calculations.
Okay. So this is okay, right? So until this point, so what I have to do is I have to multiply with this prior density, right? I have this is likelihood, and into my prior density is what? F capital lambda of small lambda. Now, how to find prior likelihood here? This is just a product of I equal to 1 to 12 into, so because since these are all IID samples, right? So so, and what is the density for this? It is exponential with parameters lambda,
Lambda.
right? So it should be e to the power minus lambda into lambda to the power x, sorry. This is exponential distribution, no? So
Yes.
lambda e to the power minus lambda x, right?
Yes, yes. Lambda will come.
So lambda e to the power minus lambda x I.
Yes, yes.
Okay. So if I do the product, how it will be then? if I do this product,
We need to
okay,
take
yeah,
Lambda
again,
raised to n. Lambda to the power 12
and what is this? Okay, tell me this first. Into f lambda of lambda, this is what, e to the power, sorry, 1 by 20, sorry, here it was there, no, is 1 by 20 from here, correct? This
Because
prior
4
density, right?
minus lambda by 20.
Yeah, so this is 1 by 20 e to the power minus
minus
lambda
lambda by
by
20.
20. Now again product, so if you multiply lambda 12 times, what it will be, lambda to the power 12. Then if you multiply e to the power minus, so it will be like this, right? E to the power minus lambda x1 into e to the power minus lambda x2 into e to the power minus lambda x3, like that.
minus
So
lambda will be common as e to the power minus lambda
into
x1
x1
plus x2
plus x2 to
plus x2 up to
3x12.
x12
x12.
plus
Okay,
1 by 20 plus 1 by 20.
okay, you can say, so you can add this actually, right? Okay, we'll
Yes,
go
right.
step by step. It's okay, we'll
Okay,
go
okay,
step by
sorry.
step. Okay.
Yes, yes.
So into 1 by 20 e to the power minus lambda by 20. Okay,
Mm,
it's fine.
fine.
Okay, so I'll moving to the next page.
Fine.
It was what, e to the power, sorry, lambda to, what was it, lambda to the power 12, then e to the power minus lambda into x1 plus x2 to x12 into 1 by 20 e to the power
Minus
minus
lambda
lambda
by
by 20, right? Is okay. Now what, so here e to the power minus lambda, and these are two same bases, right? E, and this is not, there is no same base for lambda, so I'll write lambda to the power 12 and 1 by 20 here, this 1 by 20. Okay, I'm writing 1 by 20 here, right? This is lambda to the power. Now I can write e to the power minus lambda x1 plus x2 to x12 into what, this is also minus lambda by 20, right?
yes.
So I can take common minus lambda and I'll add
Plus 1 by 20.
1 by 20 here. This is okay?
Yes, okay.
Yes.
Okay, okay. And anyway this is proportionality sign, right? It's not equal sign, and proportional to some constant doesn't make any sense, so we'll just remove this. So this looks like this, right? So this is my what, posterior. So posterior density is directly proportional to lambda to the power 12 into e to the power minus lambda into this. So this seems like some known distribution to us, right?
Gamma distribution.
So okay, gamma distribution. So what is the density for gamma distribution? It is directly proportional to lambda to the power alpha minus 1 e to the power
Minus beta lambda.
minus beta lambda.
Lambda.
So by analogy, this equation and this equation, this looks like some gamma distribution, right?
There is some gamma function also, sir. When we write
Yeah,
gamma
yeah,
probability.
yeah. But for now, just look at this. So this looks like gamma distribution. So by analogy, you can say alpha minus 1 equal to
12.
12, right?
Yes.
Which is alpha equal to then
13.
13, and beta is equals to this part, right?
Mm.
So beta is equals to what, x1 plus x2 plus x12 plus 1 by
1 by 20.
20. So what is x1?
All those values are there. Yes.
23 plus something, right? What are the values?
The total comes out to be 300.
So this is so entire total is
300.005.
So let's say 300. So my alpha is 13, beta is 300. This is this I know. So this we have calculated actually, right? These parameters. Now I wanted to find posterior mean.
Sir, beta is 321 upon 20, sir.
Okay, calculate. What I don't know what is the value. Okay,
Yeah, because x1 to up to x12 it is 300.
And 1 by 20 will
yeah,
be 0.05, na?
so this
Yeah,
will be
321 by
300.05.
20. Yeah, 300.05.
0.04.
right. So whatever values are there, just plug in these values, and I know what is posterior mean, alpha by beta, right? So that is 13 divided by. So if you do the calculation, it should come out to be 0.04. This is correct?
Yes.
Hmm.
For our correlation, if you give the alpha beta kind of notation, it will be easier for us to follow and understand, sir.
Sorry.
While we are comparing with alpha beta, because these ones are nothing but alpha by beta. What we have, we are taking from the gamma distribution. Sir.
Correct.
So if you write alpha beta also, then we can easily correlate. Otherwise, it is taking a lot of time to come back and.
No, we have written here, right? Alpha by beta.
In the printout, sir.
Printout? Which printout?
This one.
In the exam you are talking about, or here you are talking about? I'm sorry, I don't understand.
Exam is longer distance actually. When we are trying to answer these questions and all like that, then if you give alpha beta over here itself, then we can correlate very fast.
No, where you wanted alpha beta?
Because every week you are dealing with a new concept or subject kind of thing. There are chances that same gamma, same alpha will be there from the past couple of weeks and in further weeks also. So in this solution, sir.
In this solution, in the slides you are saying, huh?
Yes, sir.
Okay. Okay. I'll add and I'll share with you. Okay, that's okay. That is perfectly fine. Okay. So we'll move to the next question. So this is the question number 3. So okay, now you have to solve this question. Okay, whatever we have discussed now, you have to use the same thing but some different parameters. Now, marks of 10th class students of a school follow the normal distribution with an unknown mean mu and variance 36. Okay, so which parameter is unknown here?
The mean one.
Mean for what?
Mean.
Mean for the
Sir.
population distribution, right?
Yes.
Yes.
Right. Marks of 15 students. So what is this marks of 15 students is what? This is a sample, right? Sample of 15
Yes, sir.
students. We know the sample of sample marks from the 15 students, which are 50, 60 like this. Now find the Bayesian estimate, that is posterior mean of unknown parameter mu, assuming the prior distribution as normal 70-25. What is this now? This normal 70-25 is what?
Prior distribution.
So that means this is a distribution for what?
For mu. For mu.
For
Mu
the
and
mu.
Mu.
Okay, for the mu, which is unknown parameter.
Yes.
You are understanding now the thing, right? Population mean is mu, and this mu is also a random variable, and it is having a distribution of normal 70-25. You're able to understand, right, what I'm trying to
Yes,
say?
sir.
Okay. So you use the same setup. This is nothing but the same problem what we have discussed earlier. There it was like exponential distribution was given for the distribution mean, and the prior distribution was also exponential there. Here what is the difference? The population mean is a normal, like a population distribution is normal, and prior distribution to the unknown parameter mu is also normal with parameter 70 and 25. Okay, this takes yeah.
Sir, in this, if so in this, as the sir said in the lecture that he derived it for the conjugate prior normal. So, sir, can we use the direct formula, or
Yeah,
will
you
we
can
have
use.
to?
No, you can use direct formula here.
Sir, but we have to means first to remember that, right? No formula.
Yeah. So
that won't be given, right?
So no, this kind of formulas will be given. If some direct formulas are there, right, it will be given.
So also for this posterior mean, it will be given.
Yeah.
Like.
So since it is a very difficult formula to derive also, right? It's
Yes,
not that
sir.
easy. You have to do. So we'll give if this kind of thing is there, na? If normal distribution is given, then it will give.
Okay.
If for other distributions, it is easier to find. It's a multiplication. Here also we can find, but it takes a lot of time.
Very much time.
Yeah.
And also for other distribution, it might take some time.
Yeah.
Means, so for other distribution also, are you?
No. Other distributions
Right.
won't take time, right? See, for
No,
if it is exponential distribution, what is this? A to the power minus lambda into
Ah.
lambda to the power
X.
right, x. So what you will do? You just it is
Sum.
lambda e to the power minus lambda x. So e to the power lambda, if you multiply by n times, it will be e to the power lambda n, right? And e to the power minus lambda x. So it is e to the power minus lambda common, and x1 plus x2 to that thing. If it is Poisson distribution, then how it will be the product? So what is Poisson distribution for one sample? It is lambda to the power x into x, lambda to the power x into e to the power minus lambda into lambda to the power x divided by x factorial.
Yes.
Right. So first term e to the power minus lambda, if I'll multiply n times,
N lambda.
E to the power n lambda, right? Then lambda to the power x. So lambda to the power x1 into lambda to the power x2, like this. So I'll say directly lambda is same base is there. So lambda to the power x1 plus x2
Plus
to
x2.
that thing. And divide x1, x factorial is actually a constant, right? So we will
can
ignore that. So this, like, these common distributions are very easy to find, right? If it is a Bernoulli distribution, then what you have to find? How many times 0 is occurring and how many times 1 is occurring in the sample?
Yes, sir.
So that many times you are saying to the power p for when it is 1, and that many times you will say 1 minus p to the power something, right? So p to the power 5, if 5 times my 1 is occurring, 1 minus p to the power 5 or 6, how many times 0 is occurring?
Okay.
And mostly we'll play with this only, the exponential, Poisson, or Bernoulli, maybe in case binomial. Apart from that, mostly we won't.
Binomial also, sir has not taught any example on that, but
yeah, but we can see, right, this kind of things.
Okay. Sometimes
normal mostly we won't ask. Like normal is difficult, and if you ask, right, we'll provide you with the formula.
Yes, because to derive that or to get to the posterior mean
it
for
will
normal,
take time, lot of time. Yeah, this is not that easy.
Yes, sir.
Okay, take some time and just try to solve this. I have got already 4 responses, so take like 5 more minutes and we'll discuss.
null. Hello.
Okay, I'm audible, right? Sorry, I got disconnected.
Yes, sir.
Okay, so we have to wait for 2 3 minutes. Yeah, I got like 11 responses until now. 69. Okay, what was the question? Question was mass of progress. Okay. Okay. अरे तो अब भी हो जाता मतलब अभी तो हो जाना चाहिए था इससे वापस में क्या किया था कि 3 करवाइए Okay, so we'll see the solution now. Yes. Okay, the correct answer is I think 60.87.
Yes, sir.
I think a lot of people have given the correct answer. 2, 3, 4, 5, 6. Yeah, mostly. Out of 11, 3 students did give wrong answer. Only others are given correct answer. Okay, so we'll see the solution now. So we know that the normal distribution is a conjugate to the normal distribution, right? That means if we have a normal prior, right, then it is a conjugate to the normal distribution. So we, in this case, we had mu, the prior distribution of mu, which is the unknown parameter, having a normal distribution with mu naught and sigma naught square, and sample is taking from a distribution which is normal mu sigma square. Then the posterior distribution of that mu will be normal with mean x bar into n sigma naught square divided by n sigma naught square plus n sigma square plus mu naught into sigma square divided by n sigma naught square plus sigma square. Here we know x bar is what, 60, n is 15, mu naught is 70, sigma naught square is 25, and sigma square is 36. Why x bar is 60? So this is the sample we have given, right? What is x bar? It's a sample mean.
Sample mean.
So it's like 50 plus 60 plus 92 plus 42 until 33 divided by 15. So it comes out to be 60. N
60.
equals to 15, we know number of samples. What is mu naught? Mu naught is a mean for a prior distribution, so which is equal to 70. Since we know that the prior distribution is normal 70 25, so it is 70.
Yes.
Right? Sigma naught square is 25. It is a
25.
variance for a
Prior.
prior distribution, right? And sigma square is known, which is 36. The only value which is not known is
Mu.
Now we are finding for that only, right? So posterior mean is equals to, so this is the formula which we are using, x naught x bar into this thing. So just plug in all the values, we will get the answer 60.87. So we are not going into details like how to derive this formula. I think sir has derived it, but if it is not, kind of difficult.
It's not very clear also, sir.
Yeah.
But
it's okay. So we can use this one.
Sir, will we get this formula for, I mean, if something like this,
if it
question
is there, right, in the quiz
normal
paper,
distribution type of case.
If it in the paper, we'll provide. If it is there, we'll provide. Mostly we won't give the questions on normal distribution. Okay.
Actually, Prof had just stated this. He said, I leave it as an exercise for you guys to do.
Yeah.
So if anyone of you wants to derive it, you can derive it, and you can post it on the discourse, and we'll say if it is correct or not, or else we'll also, if somebody has already posted and created a discourse thread, right, we'll also share our solution or how to derive it. Okay, that will do. Okay, so we'll see the next question. So 3 out of the last 10 candidates wins a treasure hunt game. Previous record shows fraction of winners follows the beta a comma 6 distribution with an average of 40%. Estimate the long-term fraction of winners of the treasure hunt game. Okay, now here I wanted to ask you 2 questions. You just have to give me the answer. What is the let's say population distribution here?
Beta.
This beta is what? Population distribution or prior distribution?
Prior, sir.
Prior, sir. Sorry, prior.
Because previous record shows that fraction of winners
prior.
is beta distribution. So it is a prior distribution with parameters
a comma 6.
6. Okay. Then what will be my okay, distribution, like distribution means like population distribution. Huh?
Binomial?
No, Bernoulli.
Bernoulli you can say, right? So x1, x2, x3 belongs to what?
0 if they have won the.
Not 0 here, it's actually the fraction, right?
Yeah, sorry, I was.
So
sir, how are we calculate concluding that population is binomial.
Why, you tell me?
I didn't get. That's what I'm asking. No?
So yeah, so the thing is, it shows that it says that the fraction of winners, right? So we are actually saying it's a fraction. So let's say it is a game, treasure hunt game. So some person will. So if there are 10 candidates who are actually participated in the game, right? So each participant or each candidate uh, is having he can win or he can lose, right?
Can't hear you, sir.
So that can be binomial
Sir,
also.
unable
No?
to hear you.
That
Is
can be
it?
binomial also.
One minute. Sorry.
Now
Am
I
I,
can. I mean, in
am
between it was going.
I audible now?
Yes,
Yeah.
yes, you're audible.
Yes, sir.
Okay. So what I was saying is, okay. So it's what we are finding here is a fraction of winners, right? So that means in the out of the 10 candidates, how many candidates are going to win? So each candidate, if I say, x1, x2, x3, x10, they belongs to certain distribution. So which distribution it is? You are understanding?
So, just a basic doubt. If it is like a multiple Bernoulli, it is binomial only, na, sir?
Yeah, but
Yes.
if it is a independent, yeah, if you are repeating the same thing, then it will belongs to a binomial distribution.
So why not binomial over here? Why only Bernoulli over
So
here? Because they are saying
how
that
you
way.
wanted to take this? Uh, so here you know that sample is from the. What I'm asking is just the distribution is what? Okay, you wanted to take binomial distribution, then you are considering all the 10 candidates as one, right?
Yes, sir.
Right, huh?
In that case, you can say, so all x1 to, so x1 plus x2 to x10 is having a binomial distribution. But if I wanted to say that each candidate is independent of other, right? In that case, what is there?
Okay, in that case, Bernoulli.
Bernoulli.
Yeah, right,
Bernoulli,
right, right.
right?
Okay,
Because 3 out of 10 have one, right?
okay,
Yeah,
right.
so however you wanted to go, you can go. I'm not saying like
Okay,
how you want to go. Okay,
okay.
just take your thing and just go ahead with that. Okay,
So,
so
sir, in this type of questions where one has won or other has lost or some other type of things, we can assure that it is a Bernoulli type.
so
Two possibilities are
yeah,
given here,
yeah,
right?
right.
We can identify like that, right?
Yes. Either it is, see, zero, either he will lose or he will
He will
win, right?
win.
But we don't know what is the probability of success, right? So if
Hmm.
I have 10 candidates, I can say 0, 1, 0, 0, 1, 1, 0, 0, 0. So we know that 3 out of the 10 candidates won.
One.
So my sample looks like what? 0, 0, 1, 1, 1, and all other zeros or something else. It's sample, right? It's randomly selected. I'm giving you one sample like this: 0, 0, 0, 1, 1, 1, and
Hmm.
all other zeros, right? So each 0, 0, 1, it is a it belongs to Bernoulli distribution, right? With
Yes.
unknown parameter what? P, probability of
P.
success, which is probability of success. So you can calculate like that also, or you can say that the fraction of winners, right? It is unknown to you. You can call it as
Yes.
unknown parameter, and you can solve this. However you want to solve, you can solve. Okay. Now I know that the fraction of winners here follows the beta distribution with average of 40%, and
Hmm.
here the I do not know.
So, sir, here beta distribution mean is given 40%
Yeah, yeah,
expected value.
yeah. So prior distributions mean is given, and what we
Hmm.
have to find here now?
First,
Value of
you
a,
calculate
right?
A.
Value of a,
Hmm.
and then you have to solve for
For
fraction.
posterior mean.
Yes. Can you solve this? Try it, and we'll see the
Yes,
solution.
sir.
Okay. Take 5 minutes and we'll solve this. Okay, so now we'll see the solution, right? I think a lot of people are given 0.35 as the answer, and I think it is correct. So yeah, let's go to the solution. Okay. Now let the long-term fraction of winners be denoted by p. Okay, here the fraction of winners is taken as the parameter which is p. Previous data shows that fraction of winners follows beta distribution with an average of 40%. So what is the average of 40% means? The mean of the beta distribution is zero point 0.4. And what do you mean by a mean or expected value of beta distribution equal to 0.4 is? So what is the expected value of beta distribution? It is alpha upon alpha plus beta, right? And what is alpha
Yes, sir.
here? Alpha here is a. So a upon a plus 6 is equal to, so beta is 6. So a upon a plus 6 equal to zero point 0.4, and from that equation we'll get a equal to 4. So that means what is the prior distribution now? Beta 4 comma 6, right? So the prior distribution for the parameter which is p, which is the fraction of winners, is 4 comma 6, and we know it is directly proportional to, so the density, the prior density is directly proportional to p cube into 1 minus p to the power 5. Is correct, right? So
Yes, sir.
Yes, sir.
p to the power alpha minus 1 into 1 minus p to the power beta minus 1, right? That is the beta distribution density, right? Which is directly proportional. Okay. Now, posterior density is directly proportional to likelihood into the prior density. Now, what is the likelihood? So I know that 3 out of 10 people win the game. So that means p 3 means p to the power 3, right? Probability of success. So p to the power 3 into 1 minus p to the power 7 into the prior density, which is p cube into 1 minus p to the power 5. So if you multiply everything, you'll get p to the power 6 into 1 minus p to the power 12, which this looks like a beta distribution, right? With parameter alpha minus 1 equal to 6. So alpha will be equal to 7, and beta minus 1 equal to 12. That means beta equal to 13. So posterior density will have a distribution beta with parameters 7 and 13. Now posterior mean for this distribution is alpha upon alpha plus beta. So alpha here is 7, and alpha plus beta is 7 plus 13, which is 20. So it is 7 by 20, so which is equal to 0.35. And I think most of the people have given the correct answer. Okay.
Sir,
Huh.
then does it mean that population follows beta distribution, not Bernoulli?
No, no, population distribution was given that, but it was Bernoulli, right? Then prior distribution was beta, and my posterior distribution is
It's also beta.
beta.
Okay.
Okay. Okay. So this is the next question. The outcomes on tossing a coin 15 times are H T H H T H H T T H T H T T H. Let P be the probability of heads. Previous records show that head heads appear on an average 70% of the time. Find the posterior mean of P using the beta 7 comma beta pair. So this looks like a familiar question to you.
Yes, sir.
Like what?
Same as
Similar to
previous one.
previous
Same
one.
as the previous. The only
Previous one.
difference here is
In place of
Outcomes
alpha,
are
beta
given.
is unknown. Beta is
right.
unknown here.
Right. Now you have to solve. So don't take much time to solve. Like take 5 minutes again, and we'll discuss the solution. Okay. And I wanted all of you to be given the correct answer now.
So where can we answer the question?
Hmm.
Okay. So yeah. So shall we see the solution now? Okay. A lot
Yes,
of
sir.
people have given like 0.6 as answer. Okay. That's fine. So let P denote the probability of fits, right? Given that the prior of P is beta 7 comma beta with an average of 0.7, right? And that is expected value of 7 comma beta is 0.7. So it implies that expectation of beta 7 comma beta is equal to 0.7, right? And we know the expected value of beta distribution is alpha upon alpha plus beta. So here alpha
Yes.
is known 7 and beta is unknown. So 7 upon 7 plus beta equal to 0.7. So beta is equals to what? 3, right? Now we know what, now we got the value for beta. So our prior distribution for probability of success becomes, or probability of hit becomes beta 7 comma 3, right? And what is the density of this prior distribution now? So what is the density for beta alpha comma beta? It is p to the power
Beta.
p to the power alpha minus 1 into 1 minus p to the power beta minus 1, right? So
Hmm.
alpha here is 7 and beta here is 3. So density becomes p to the power 6 into 1 minus p to the power 2. Now posterior density is directly proportional to likelihood times the prior density.
Yes.
And I know that how many times in 15 tosses I got head? 8 times.
8 times.
So the likelihood becomes p to the power 8 into 1 minus p to the power
8.
7. 7.
Sorry, 7.
Right? 15
7.
times we have tossed the coin. In that
Yes.
8 times I got the heads. So p to the power 8 into 1 minus p to the power 7. And I know the prior density is p to the power 6 into 1 minus p to the p square. So if you multiply these things, we'll get p to the power 14 into 1 minus p to the power 9. And this distribution seems to what?
Beta.
Beta,
Beta 15 10
alpha, beta, and what will be the value of alpha here then?
15
15.
15.
So alpha minus 1 equals to 14. So alpha equals to 15. And beta minus 1 equal to 9. So beta equal to 10. So distribution becomes beta 15 comma 10. Now I wanted to find the posterior mean for this distribution. So what will be the value for posterior mean here? Alpha upon alpha plus beta. So what is alpha here?
15.
15. And what is alpha plus beta?
25.
So the posterior mean is
0.6.
0.6.
Yes.
Okay. So that's it.
So whenever we get the distribution for beta, so for posterior, we always do +1, right? Means if p raised to the power 14 is there, so in distribution we write this 15 comma 10.
Yeah.
+1 we do, right?
+1. Yeah. See, beta alpha comma beta. So the distribution for beta alpha comma beta, right, is what? Is directly proportional to what?
X raised to power alpha minus
X raised to power alpha minus 1 into
1 minus x
1
to
minus
the
x
power
beta
minus. Yes.
1. So when I say p to the power 14, so that is the value equal to alpha minus 1.
Yeah, alpha minus 1.
So alpha, the value of alpha will become 14
15.
plus 1, which is 15. And
14.
here 1 minus x to the power 9, right? So it is beta minus 1. So beta minus 1 equal to
10 minus 1.
So equal to 9, right? So beta equals to 10.
10.
Right?
Okay.
And that is the alpha beta for the beta distribution.
Okay.
Sir, are we done with questions?
Yeah.
Sir, I have only two small doubts, quick doubts, sir. The first one is like I was asking in between, then I kept quiet.
Okay.
Like while writing PDF of gamma distribution, so PDF has some gamma function, but while writing we are ignoring that. So what is the reason behind that?
Yeah. So the reason here is the denominator there is, right, that is constant, and what we are seeing is which is directly proportional to, right?
So even gamma function is constant or what?
Yeah. No, it is having some constant in that, right?
Gamma raised to gamma into alpha time. Some capital gamma is there.
So, yeah, gamma is a function of alpha, something like that. It comes in the expression.
Yes.
So you're saying that we have to ignore, huh?
Yes, because see, posterior density, when we are finding out, it is, what is the sign?
Proportional to.
Yeah, we are not going for equal to. So when it is proportional to, right, when we are saying it is proportional to something, then it should not be constant. It should be very.
Just for understanding, sir, are we saying that those two components, because we are ignoring something from numerator and something from denominator?
This is because it is
that is constant, huh?
Yes.
That is always constant. Okay.
Yeah. So when we say proportional is when it is.
This is clear, sir. This doubt is clear. Sir, one more thing. Can you come to question number 1, sir?
1, huh?
Yeah. That is also very trivial doubt, sir. It will not take more than 1 minute.
No, it's okay.
Yeah. Question number 1. Yeah. Just let us move to next slide, sir. When we are writing solution. Next, yes. Sir, it's a very trivial doubt for me, sir. Whenever I see this, condition statement like probability of x equal to 9, condition on lambda equal to 5, right? So fundamental doubt comes to my mind that this is nothing but the conditional probability, right?
Base rule, yeah.
Yeah. Just look
conditional
into this.
probability.
Just look into this part only, right?
Yeah.
So we are habituated of writing it as probability of x equal to 9 intersection lambda equal to 5 divided by probability of lambda equal to 5, right? We are habituated of writing like that, like probability of A given B is nothing but probability of A intersection B divided by probability of B, right?
Okay, yeah.
So say for example, if by mistake I take that route to solve this problem, so where I will stuck, sir?
Nothing.
Can you write it in that way, like probability of x equal to 9?
Yeah. But the thing is, then you should not cancel that see, what will happen? Probability that x equal to 9 given that lambda equal to 5, it is equal to probability that x equal to 9 intersection lambda equal to 5 divided by probability of lambda equal to 5,
right?
So what you are going to do then? You will cancel out this thing, right? Probability of lambda equal to 5.
Can we write it like that, sir, and solve it?
No, but then do you know what is the intersection of x equal to 9 and lambda equal to 5?
No, I don't know.
No.
Then see why we are doing the probability of lambda equal to 5 given x equal to 9. So why we are writing this in this format is we know this value, probability that x equal to 9 given that lambda equal to 5, and we know this lambda equal to 5, probability of lambda equal to 5, right? How I know this probability that x equal to 9 given that lambda equal to 5?
Yes, so yes, how we know the value of first expression like probability x equal to lambda equal to 5? How do we know?
Yeah, so it is given here, right? Since the number of customers reaching a particular shop in an 1 hour period time period follows the Poisson distribution. So I know that
Okay.
my distribution, the
So
population
the PDF
distribution,
of Poisson is PDF of Poisson is e to the power minus lambda into lambda to the power x divided x factorial.
right? And given that lambda equal to 5, that means I know. So what is the conditional probability? You know something, and based on that we are finding the probability for other thing, right? So
The condition probability is the intersection divided by marginal.
don't know these terms. See, basically what is here? What does this mean? X probability that x equal to 9 given that lambda equal to 5. What probability we are finding out? When I know the value of lambda equal to 5, I wanted to know the probability that x will take value equal to 9.
Okay. Okay, so we have to consider like this, right?
This is the meaning of it, right? The conditional probability.
Okay, we have to think like this, right?
So I know that
and now my x follows Poisson distribution, right?
Yes. Okay. And given that lambda equal to 5, that means when my lambda will take value equal to 5, what is the probability that x will take the value 9? And I know that x is my Poisson distribution, which is equal to e to the power minus lambda into lambda to the power x upon x factorial.
Like that is not a blanket approach, like intersection by marginal. That's not a blanket approach, right?
Yeah. So what you can think is, I will use that formula when I know how
intersection part.
Yeah. What is the intersection part tells you?
Okay. The common intersection is common in both.
Yeah. That means when my lambda equal to 5, how many instances are there when I'll have lambda equal to 5 and x equal to 9 samples? 9. So okay, one more thing I'll tell you is, what do you mean by Poisson distribution? What do you mean by this first line? Suppose that a number of customers reaching a particular shop in a 1 hour time period follows the Poisson distribution with unknown parameter lambda. What does this tell you? That means, let's say in 1 hour, let's say 9 people come. Okay, 9 customers come. In the next hour,
that's the average.
5 come. In the next 1 hour, it is some 7 come. In the next 1 hour, like that, right? And on an average, I know that this follows a Poisson distribution. So the number of customers coming to a shop in 1 hour period follows a Poisson distribution. That means sometimes 9 will come, then 5 will come, 7 will come, 10 will come, 7 will come, 9 will come, like that, right? With some parameter lambda, right? But when I'll say I know that the parameter is lambda, the parameter lambda is equal to 5, in that case, what is the probability that x equal to 9? That means how many times, let's say I saw 10 instances, okay? So in first 1 hour, 9 came, second hour, 1 hour, 5 came, the third 1 hour, 7 came, then again 6 came, then again 9 came, like this. So in the 10 instances, how many times 9 occurs? When lambda was equal to 5.
But here parameter lambda equal to 5 means average number of customer coming in 1 hour, right? Lambda stands for
correct. So average number of customers coming
is 5
by is equal to 5. That means it is not always 5, right?
Okay, so we are trying to find out that what is the probability of coming, 9 customers coming in that
coming
hour, right?
When my average is 5.
Okay.
So think about don't think about the Poisson distribution right now. Let's say it is a Bernoulli distribution. Okay, and it is having some average or not Bernoulli distribution, I can say. But okay, understand it physically like this. There are different number of customers are coming in 1 hour, right?
Yes. Now
but average number of customers coming are 5.
Yes. Average is 5, but different number may come, right? So what is the probability of getting that number?
Correct. So for 10 hours, this as 10 hours. In 10 hours, different customers will come, but the average of all the customers coming is equal to 5.
5, yes.
Okay. So I know when average is 5 and these different customers are coming, what is the probability that 9 customers came in that 1 hour? So it might be possible that 3 times out of 10 are coming.
So can we say 0.3 is the probability then in that case?
Correct.
Okay.
Right. This is the physical meaning of it.
Yes.
In this way, you are doing it mathematically, because we don't know how many times it is coming, right? This is what I am trying to say in.
No, got it, sir. Got it. I was confused with that only intersection divided by marginal.
Yeah.
So you are saying that we should not take that approach every time, right? Until unless the intersection is given, right? Yeah. Until unless intersection is given, we should not take that approach, right?
Yeah. So when you will do this, when I know in the 10 instances, I know 3 times it is coming. So that, what does that mean? I got x equal to 9 equal to 3. Sorry, x equal to 9 and lambda equal to 5. How many times?
3 times out of 10.
Yeah, like this. Consider like this.
That is 3 by 10. That is 3 by 10,
not,
right?
Yeah, concretely correct what I'm trying to say, but this is what meaning is.
Yeah, it makes sense, sir. Thank you, sir. Thank you.
Sir, I have a doubt.
We can...
Activity 10.4, question number 3. Can you please explain?
We have one more session tomorrow, right? We have one more
sir, that is for 11. That is for week number 11, sir.
Week number 11 or week number 10?
No, week number 11 dedicated for that, sir.
Okay, 1 minute.
Yeah, because that is in continuation of something, sir. So we don't want to break the chain.
Okay. So I need to check which is the activity.
Activity 10.4, question number 3.
1 minute.
Sir, one doubt. Sir, will this additional content will be coming in the exam point of view?
No.
For exam?
Additional content means?
Sorry, the additional lectures. In each week they are given, right?
No. In the exam it won't be there. You'll have time, you can watch it. Otherwise, it's okay if you don't watch it. Okay. Which activity question? Hello.
10.4, question number 3.
Okay.
Sir,
based on the information, right?
Yes, sir. Just like I have found the prior using expected value of prior. I have found that beta is equals to 2 by 3 alpha using this value 0.6.
But 0.6 and prior standard deviation also.
Yeah, and using standard deviation, I have to find the second relation between alpha and beta.
Yeah, so here what happened is, here you have two unknowns, right? Alpha and beta, two unknowns. So you have to form two equations.
Yes, sir. I have found from first equation from expected value of prior. Alpha by alpha plus beta is equal to 0.6. Yes,
the second equation.
And for variance, for beta function variance is alpha beta divided by alpha plus beta square into alpha plus beta plus 1.
Right. Equal to 1.5 square.
Yes, I use this formula, but the value of alpha I am getting is 0.36. Is it correct? Because it is not fitting into the answer that is given.
Okay, somebody solve this question.
Yes, sir, I have solved.
What is the answer?
Sir, for this alpha was coming to be... Just a second. So which question? Question 3, right?
3.
Sir, alpha was 5.8.
So okay, what makes, what happened here? I think you did some wrong calculation.
Which question? Sorry, which question?
Activity question 10.4, question number 3.
Alpha was 5.8 and beta was 3.86.
So who was there? I forgot. I'm sorry. What was your name? You were asking the question. I think your answer is wrong.
Yes, sir. I am getting a wrong answer. Can you please solve it?
Okay.
I know the steps, but
Yeah,
I am getting it somewhere wrong. I just need clarification.
Okay, fine. We'll see. Yeah. No issues. So here, two equations will be there, right? Alpha upon alpha plus beta equal to 0.6. And what is the equation for this variance?
Alpha beta whole divided by alpha plus beta whole square into in denominator itself alpha plus beta plus 1 in bracket alpha plus beta plus 1.
Is this correct?
Yes, value is 0.15.
Yes, sir. Yes, formula is correct.
Right. This is not 1.5, right? This is 0.225, right?
Okay.
0.15 square. I think you are making that mistake there. This is variance formula, na?
Yes, sir. Yes, sir.
So you
Point
have,
0.0225.
sorry, yeah, 0.0225. Yeah, that's. So just check. I think your calculations are having, because of this thing, right? Your calculation might got wrong. Otherwise, there is nothing. Because from here we will get one equation, right? Alpha equal to 0.6 alpha plus 0.6 beta. 0.6 beta, right? And here it will be 0.4 alpha equal to 0.6 beta. So alpha will be equal to 0.6 by 0.4. It is like 3 by 2, right? It's 1.5 beta, correct?
Yes, sir. Alpha and
Alpha equals
beta
to
relation.
1.5 beta, and if you substitute this value here, we'll get something. So it is 1.5 beta square, 1.5 alpha, so 1.5 is 2.5. 2.5 square is what? 6 point,
0.625.
6.25, right?
0.625. No, 6.25.
6.25, right?
Yes, sir. 6.25. Yes.
Beta square plus here it's 1.25 alpha. So 1.5 plus 2.5 beta plus 1 equal to 0.0225, and then you will get some equation and you can solve it, right? I think it will become quadratic equation, I think, right? You will get values. So just try. I think because of this you made this mistake, right? You just equated the standard deviation with the variance. I think because of that you were
Exactly, sir. I made that mistake.
uh,
I
that's
will. Okay.
okay then. Okay,
Okay,
guys.
sir.
Bye bye.
Thank you, sir.
Sir,
Yeah,
sir,
thank you, guys.
one small thing I wanted to
Hmm.
bring it to your notice, sir.
Yeah, please.
Tomorrow is the last date for
Yes.
GR
Week
this
10.
one, sir.
Week 10, yes.
Week 10. And on Sunday, actually, week 11 is also there, sir. But actually, when uh, our uh, our other program is there, Python kind of thing, and most of the people are coming from there. In fact, they are having the proctor examination on the same date, Sunday.
OPP, yeah.
Yeah. So if the submission date is changed to just Monday kind of thing, there will be some breathing time for the people to
Okay,
make it
so
well,
you're
sir.
saying some.
Even the site doesn't work on that day, sir. That's what he's trying to say.
Okay,
Even
okay,
the
okay.
site does
I
not,
will, I'll check with my
function.
team. Yeah, okay, okay. I'll just
Yeah.
inform the team. Okay.
Thanks,
Okay,
sir.
okay. Thank you for noticing this. Okay. We'll
Thank you,
see
sir.
like what we can do.
Yes, sir. Thank you.
Yeah.
Thank you, sir. Good night.
Thank you, guys. Thank you. Good night.
Good
Bye
night,
bye.
sir. Good night.
Thank you, sir. Good night. Thank you very much.